Hello everyone. So in this video we are going to implement a MATLAB code to understand the property of linearity in a better manner. We have already done the mathematical examples and we also seen that a linear system follows two property, that is property of homogeneity and additive property. So now I will show an example. So here we are using some example, and by this example we can check the linearity of a system. So for the first example I'll write some codes and I'll explain them step by step as I go further. So here first we'll take a variable a is equals to 2. So we are saving a value of 2 in the variable a. So now a will take a value of 2. Now we also define a variable n and we will save a value of 2 again in this variable also. Now we will define the system relationship. So s will be equal to @x. So here x denotes the variable and we will define our relationship as a into x dot to the power of n. And I have already explained in the previous video that this dot is bitwise operation, for the bitwise operation, because x will be a vector. So now we have defined the relationship. Here if we will put these two values here, so the relationship will be s is equals to 2 into x square. So that is our relationship, and we will see that this function is linear or not by doing the operation here as. So we will first take some values for x1. So x1 will be taking some value from varying from 1 to 4. So now x will save a value of 1, 2, 3, 4, and similarly we will take another variable x2 which will save value from suppose 4 to 7. You can take a value whichever you want in your code. So now this will take a value of 4, 5, 6 and 7. So now as we know that from the property of linearity that we will check s of x1 plus s of x2. So what will the value of these two variable x1 and x2 for that relationship, and then we'll add them. So that will give you the value of 34, 58, 90 and 130. Now what we'll do, we'll calculate the value of relationship or system using the variable x1 plus x2, and if the value of s of x1 plus s of x2 will be equal to s of x1 plus x2, then we will see that the system is linear. But as we already know that x square doesn't follow the linearity property, so you can see that these two values are different, and that shows that the system is not linear. So this is the case. So now we'll again take some value and we'll see an example of a linear system. So can you suggest a value of n in which a system became linear in the same equation? So yeah, you guessed it right, like we can take a value of n is equals to 1. So here I am going to take a value of n as n equal to 1, and now I am going to again define our function, and then we'll calculate these two values. So we'll be calculating s of x1 plus s of x2, that will be values 10, 14, 18 and 12, and then we'll again calculate your s of x1 plus x2, and as you can see that these two values are same. The only difference is that earlier we were using n is equals to 2, that was making that function a into x square. Now we are taking it as n is equals to 1, so the function is a into x. So and you can see that a into x is a linear function and the earlier function was non-linear, and these are explained by these two values. So this defines the MATLAB implementation to check the system linearity.